Okay, so today we're going to talk about the coordinates on that unit circle. And whether you realize it or not, you already know what those coordinates are. I want us to think through that unit circle for a moment, okay? And let's look in particular at pi over 4. Okay, so let's say this is my angle, pi over 4. All good? Now, if I drop a line straight down from here, okay, this is the height of y. The y coordinate of that point. That's what that line would be. And this is the x, correct? So how much I move over to how much I move up, that would give me the coordinate here. I hope that makes sense to you. Now, in thinking about this, I want you to, again, stand here at this angle, like as if this is you standing here. This is also known, this side here is known as, yes, it's y, but it's known as the opposite. Are you with that? So this is also known as the opposite of where I'm standing. And this line, yes, it's the radius, but in terms of this triangle is called the hypotenuse. And what do we know as being called the opposite over hypotenuse? Where have we seen that ratio before? Sine. And as we pointed out, this is y, right? So what we're saying then is that y, right, is equal to, get this, okay, I want you, or rather, I should say it this way, the sine of that angle, I'll write it like that, the sine of that angle is equal to opposite over hypotenuse. Still good? And we know the opposite is y value. That's what this measure is. And the hypotenuse, if we're talking about the unit circle, is 1. So what I am telling you here is that the y, part of the coordinate, is the sine of that angle. Similarly, let's look at next to here, okay? So now let's look at that one. What is that also known as? This is your x, right? And if I was to talk about it in terms of the triangle, it would be also known as the adjacent to that angle. And we know that the cosine of the angle is adjacent over hypotenuse. And similar to what we just did with sine, we know that the adjacent is known as x, and the hypotenuse is 1. So what we're telling you then is that cosine is the x part of the coordinate. Now, one way to remember that is they're written alphabetically. In other words, cosine, C comes before S, x comes before y. So hopefully that helps. When we're doing this then, if I know what the cosine of the angle is, then I know what that x value is. So let's think through what that looks like. So what that looks like then is cosine of pi over 4, comma, sine pi over 4 would be the coordinates of that spot. And we could go all the way around this circle and do the same for 5 pi over 4 and 3 pi over 4. I even messed that up, sorry. 5 pi over 4, 7 pi over 4. And those coordinates are going to be the cosine of that angle, comma, sine of that angle. So let's do this. What is the cosine of pi over 4? Root 2 over 2. And the sine of pi over 4? Also root 2 over 2. Okay, let's do the next one. The next one is 3 pi over 4. And so when we're doing 3 pi over 4, if I want the cosine of 3 pi over 4, it becomes a little bit more obvious here for a couple reasons it becomes obvious. First, we know that cosine is negative, right, in the second quadrant. We can see that because cosine is the x value, right, and the x's are negative. Doesn't it make sense that this would be negative, right? Negative root 2 over 2. Now, sine is the y value. Is sine positive or negative in the second quadrant? It's positive, and so is y. So it would be positive root 2 over 2. Let's look at the next one, 5 pi over 4. What do we know about x and y in this? They're both negative, and it's negative root 2 over 2, negative root 2 over 2. I want you to notice that the x and y values, for the most, they're the same proportion. They're still root 2 over 2. Every single one of these is going to be root 2 over 2. Every one of them. But what we don't see is the sine thing that's being added into this. So that's the beauty of where we're doing the unit circle here. So 7 pi over 4, we see x's are positive, so that's positive root 2 over 2, but it's going down, and so the y's. So if I asked you for the sign of 7 pi over 4, I can see really quickly from that coordinate, boom, negative root 2 over 2. I've got the sign there, I've got it all. You can see how the unit circle is actually a combination of that reference chart that you've already done and the graphs all in one. It's everything. Let's look at pi over 6. Same idea, thinking about the circle, okay? So we're going to do the circle, but now we're talking about pi over 6. So a little bit different angles here. So we've got pi over 6, we've got 5 pi over 6, 7 pi over 6, and 11 pi over 6. And so similar to what we just did with the pi over 4, you're going to basically figure out, okay, what is the cosine of pi over 6? And that would be that coordinate, sorry. And then sine of pi over 6 would be that. If you forgot, remember your chart, right? And pi over 6 was that first angle. And so if I want the sine, if you remember, it was 1/2. And so that means that this would be root 3 over 2, comma, 1/2. That means that every single one of these coordinates are root 3 over 2, comma, 1/2. It's just the sign piece that we have to pay attention to, meaning positive or negative. So in the second quadrant, we have that the x's are negative, but the y's are positive. In the third quadrant, both of them are negative. And in the fourth quadrant, just the y's are negative. And we just did that. I believe in your homework assignment tonight that you have to basically figure out pi over 3. Remember now that your quiz is basically going to entail tomorrow, well, actually not tomorrow, not because you're watching this, of course, this weekend, but it's going to entail all of the angles and all of the coordinates after we've reviewed them in class. So be prepared to know how to place all of that, the angles and the coordinates on your unit circle.